Hello, my name is Brian Barnico, and the project I chose to do was the web server and the RAID array. The rationale for this project is this project addresses the need for a cost-effective platform for hosting web applications or serving static content. By combining the affordability and low power consumption of the Raspberry Pi with the data redundancy of the RAID array, this project aims to create a reliable web server solution suitable for development environments. These development environments could be used for personal websites or small-scale developments where data integrity and uptime are important without incurring significant hardware costs. This project used 5 different architectures. The first architecture that I used was the processing subsystem. This processing subsystem houses the SoC. The SoC is crucial for basic operations of the Raspberry Pi, like running the Linux operating system, executing the web server software, managing the RAID array, providing network connectivity, and interfacing with the USB. Without this subsystem, the Raspberry Pi would not function at all. The second architecture that I used was the memory subsystem, which houses the RAM. The RAM is critical for the Raspberry Pi web server with the RAID array, because it directly impacts on the server's responsiveness and ability to handle traffic and the overall stability of the software. Choosing a Raspberry Pi model with sufficient RAM for this project is very important, because if you didn't have sufficient RAM, the project would not run very well, and it would not be for optimal performance. The third architecture I used for my project is the I/O subsystem. The I/O subsystem holds the USB ports. These USB ports are used for the RAID array's data. These USB ports are essential for connecting the external hard drives to create the RAID array. This data transfer speed supported by the USB interface directly impacts the speed at which media can be read and streamed from the RAID array, which is very important for the functionality of this project. The fourth architecture that was used was the storage subsystem, which houses the SD card interface. The micro SD card hosts the bootable operating system and the web server software, like Apache, PHP, MariaDB, and WordPress. A reliable and reasonable fast SD card ensures smooth system startup and efficient operation of the underlying software that manages both the web server, and the RAID array. The I/O subsystem that I mentioned in the last architecture manages the communication with the operating system. The fifth and final architecture that I used was the power management subsystem. This power management subsystem ensures a stable and adequate power supply to the system, including the power hard drives in the RAID array, via the USB subsystem. Consistent power delivery is paramount for reliability of the web server and the integrity of the RAID array configuration. Preventing data corruption and ensuring continuous operation, the SoC and dedicated power management circuitry on the board work together to distribute power effectively and efficiently. The procedures I followed to finish this project were provided with the websites on Brightspace. The websites showed me how to install Apache, PHP, and MariaDB, which are the building blocks for WordPress, which operates the web system. After I downloaded WordPress, I worked on setting up the RAID array. To set up the RAID array, you need one USB drive as storage. After I ordered the USB drives, I installed the Scheme RAID controller and created the RAID volume. After I made sure both of these are operating correctly, I looked at the RAID volume. Unfortunately, I didn't get my project to work by the end. So I don't have anything to show for functionality because it just kept crashing on me before I could get anything. And the first troubleshooting I occurred was when I first started trying to download Apache to the Raspberry Pi. I found out I was mistyping the package name. This led to consistent download failure. I was typing it with Apache instead of Apache 2, so the file wasn't calling to the right name and downloading correctly. I only figured this out after I tried to download WordPress and WordPress wouldn't work because the building blocks to make WordPress work wasn't downloaded properly, which was Apache. Unfortunately, I had to check all the other ones before Apache. I checked MariaDB and PHP before I checked my Apache. I figured it was Apache over the other ones because I re-downloaded every software, and then that's how I discovered that the Apache software wasn't downloading correctly. I went into my code and I figured out that my correction that I was calling it in the wrong way, so I fixed that. After I figured out all that, unfortunately, when I was leaving the lab, my SD card fell out of my bag, so I had to restart from scratch again and get a new SD card, which set me back a little bit. Another issue that I had was when I was setting up my RAID array. When trying to set up my RAID array, I kept making an error. It kept making an error, which I figured out was because I had the incorrect device name for the RAID array. So when I was trying to mount the array, it wouldn't call the right file because the name was wrong. So it would just give me the error. I figured out why it was giving me this error by backtracking through my steps and finding out that the names didn't match. I quickly changed that and the RAID array fixed itself. But the main reason why I don't think my project worked was because I only got one 8 GB flash drive, while the website that I was following the steps for said that I needed two 8 GB flash drives. By the time I figured this out, it was too late. I couldn't find a store to have them, and I couldn't get it to work. The reason why I think this was the reason why it didn't work at the end is because different types of RAID arrays, like the RAID 1 and the RAID 0, require at least two drives to function. Using a single drive meant the RAID array couldn't initialize correctly, leading to errors and crashes when the web server tried to use the improperly set up storage. While I didn't find any obvious software errors which also could contribute to the crashing, the missing drive was likely fundamental cause of this instability. The lessons I learned while working on this project was I need to take your time and plan out everything thoroughly. A lot of the errors I encountered and the issues was because I was rushing through things and didn't plan properly. Also, I wasn't reading the instructions correctly and I was typing wrong names, typing wrong functions, which when you go too fast, it can be very difficult and time consuming to find your errors. Thankfully, this wasn't that big of a project, but if I'm working on bigger projects in the future, making small stroke errors or small little errors could take hours to days to find. Another lesson I learned was how to troubleshoot things when they don't go right the first time. Nothing ever goes right the first time when you're making a project, and troubleshooting is a very important skill to have. And working on this project, I really developed the skill to troubleshoot. And the final lesson I learned was how to better operate Linux. Before this class, I never used Linux before, and It was really a struggle at first, but by the time I finished this project in this course, I felt very confident in the Linux language. Well, that's all I have to say about my project, and thank you for watching my video.